Okay, so this will be your chapter review. Sorry, just closing my door. Chapter review. I'm going to show you the constructions that will be on the test. We'll have to do all of these constructions for the test. All right, so in those, well, I guess I'll do in the order that we did them. All right, so here we go. Oh, by the way, in general, the test is on the constructions, and then remember the class. And then two other things it'll be on is low-key problems. It'll be one of those. Can't give you practice for that one. It's just it'll be very familiar from the ones that we did. So look over that homework, and then it should be pretty simple. It's not that challenging. And then the last thing will be remember the four things: in center, circumcenter, orthocenter, and centroid. We'll do a centroid problem, and I'll go over an example of that. Let's knock out the constructions first. So construction number one, I'm not going to do them all, but I'll do the ones to remind you. Construction number one, given segment AB, construct a congruent segment. So step number one, make a segment that is longer than the given segment. Mark that C. Take your compass, measure. We're going from the left side of the left dot to right side of the right dot. If you want to draw an arc right there, you can. Transfer it onto the new segment. And just remember, I went to trying to make this dot look like this one. So I went just a little bit over. So maybe something like that. And that would be D. There's construction number one. Construction number two. I'm going to do this nice and small. Let's see. Construction number two is, I screwed up already. Remember, you need to start with a dot. There we go. I've consistently forgotten to do that. All right, so given a circle, construct a congruent circle. I'm having a little bit of trouble with my compass here. So, maybe this will work better. And I realize my hand is in front of, I'm just making the circle to start with. There we go. So given that circle, make a congruent circle. So this is not necessarily step number one, make a dot. I need to measure a radius. So from the center to any side, just make a radius. You need a radius, not a diameter. Measure that. Place it on your given dot. And let's see if I can do this without screwing it up. This is a skill. It's usually just where you put the pressure. When I forget to put the pressure on the point is when I run into problems. And there we go. There's my congruent circle. Label things. So let's say if this was circle O and that was point P, that's my labeling. So let's see, circle O is now congruent to circle P. There we go. I didn't do the label for this one. So let's see, AB is congruent to CD. There we go. All right, construction number, so this was 1A and 1B. Construction number two, given an angle, make a congruent angle. So I will give you an angle, and you will copy that angle. Step number one, I'm going to make this side of the triangle, or triangle, this side of the angle. Okay. Usually the recommendation is to make this just a little bit longer than that one, just to make sure. Open it up to any distance, and on the original angle, make an arc. Without changing, place that, and I'll make a duplicate arc on the other one. In fact, you probably want to make it a little bit higher. Notice the arc went a little bit farther. And that way, there's just no way of screwing it up when we do the next step. If you make it too small, you'd have to go back and do this again. All right, I'm going to measure the distance between here and here with my compass. You don't have to draw an arc on the original one, but if you want to, right, just assures yourself that you have the right measurement. And then without changing that measurement, do that to the new angle. And from this intersection right here, go through that, and there's your angle. So if this was angle, I don't know, angle N, and this is angle M, and I know that the measure of angle N is equal to the measure of angle M. Okay. You could also say that angle N is congruent to angle M. Either one's fine. All right. Next construction, bisect an angle. So I'll give you an angle. Larger the angle, it's easier to make a bisection. So if you want to do it to an obtuse angle, that'd be cool as well. All right, feels like the same construction. The previous one, step number one, I'm going to open this up a little bit bigger. I need to make an arc through the two legs of the angle. Okay. And then we want two arcs to appear somewhere here in the middle. So in order to do that, I usually don't change the measurement, but you can. I'm going to go from this intersection and this intersection right here. And I'm going to make arcs appear in the center. So if you don't know where the center is, just draw them nice and large like what I just did. I see the arrow on my screen is right in the way. I'll remove that. There we go. So from this intersection right here, there we go. And now this angle is congruent to this angle right there. All right, moving along. All right, so let's see, angle bisector. The next one is going to be a perpendicular bisector. So given a segment, AB, construct a perpendicular bisector. Okay, let's see, perpendicular bisector. Step number one, open up the compass to more than halfway. I need arcs to appear above and below from point A and from point B. You just have to be more than half. So I'm going to go to the center of A, arc above, arc below. Some people would switch back and forth between A and B. I'm going to do them both first. Well, you can't see that too well, can you? Okay. And then from the center of B, arc above, arc below. Okay. Connect the intersection points. And now I've made a perpendicular. Now, what did I just make a perpendicular by? Well, clearly perpendicular, but which one did I bisect? I bisected AB, so that means that is now congruent to that. All right, that's the labeling. You get three of these. They all feel similar. So this one is, I've got a segment AB again. Maybe I'll call it segment AC. And then somewhere along here, I've got a B. Okay. So I want to make a line that's perpendicular. I'm sorry, you can't see that. I'm going to make a segment that is perpendicular to B through AC. So this one, it's basically the previous construction, except I'm not going to be messing with A and C. I'm going to make new arcs appear that are to the right and to the left of B. Now, if you want to make your arc through C, that's perfectly fine, but it's not necessary. So I got an arc to the right, and now an arc to the left. Okay. I'm not even messing with A or C. I'm messing with these two arcs now. So from this intersection, I need arcs to appear above or below. If you want to do them both, you can. I think the book shows doing both. But you really only need one set. So I need to open up the compass to more than halfway. And that's halfway between here and B. And I'm going to go with arcs above. So arcs above. And then I'm not going to C. I'm going to the arc intersection to right there. So I went from here and from here. Okay. Connect the knots. Make that perpendicular. And I didn't make a bisector, so that's what you're left with. And the last one, just making sure I'm recording here. For a second there, it didn't sound like I was recording. The last one, same thing, segment AC. And this time we have a point not on it. So for instance, you have a point B right here. All right. Same construction as this one, except the point is above. I need arcs to the left and to the right of B. So I'm going to put an arc here and here. If you want to make your arc through A, you can. Doesn't have to be. Okay. So there and there. Notice it's almost through A. It doesn't have to be. And then I need arcs either above or below. Now, it looks like, I don't know. Okay, I'll make an above. What the heck? It could go below as well too. Let's see, I'm kind of guessing here how much space I need. So I'm going to go from this arc intersection and this arc intersections and make arcs appear above. Most people probably go below, but either one is fine. So there's that arc, and then from this intersection, there's that arc. And from that intersection through B straight down, you've now made it perpendicular. There we go. All right, parallel lines. Okay, so parallel lines. I'll do it in the middle here. I need a new piece of paper after this. So I need a line. We'll call that AB. And through point C, I need a parallel line to AB. Step number one, and you can go from either B or A. I always tend, because I'm right-handed, my hand's right here, I always tend to go through A. I don't know if that's true, whether it's easier or not, but I just always do it that way. So make that, and basically I'm going to do the construction of this one right here, congruent angles, just with this angle is going to appear right there. Okay, so that construction is through A, make an arc through the two legs of the angle I just made. And then without changing that distance, do that from point C. Just make sure you go down far enough, right? So right here, make sure you go down far enough. And clearly I made that arc way bigger than that arc, that's fine. Now I didn't change the measurement here. I'm just saying I made the arc, I just drew the arc a little bit longer. All right, so now I need to measure from here to here. Okay, and apply that to here. And once again, you don't necessarily need to draw this intersection right here if you don't want to. I'll draw it just to confirm I'm there, and take that measurement and apply it here. Now from C through this intersection is your parallel line. So from C through that intersection is your parallel line. And there we go. All right, so let's see, we've done 1, 2, 3, 4, 5, 6, 7, 8, number 9. All right, new sheet of paper. Let's see what's left. We got parallel lines. We need to do circumcenter, in-center. All right. So in order to do that, we need a triangle. Oh, I'm sorry. We need to do tangents next. Tangents, that's right. All right, so let's draw some circles. You can tell I'm very enthused about circles. For some reason, the last couple of days, I've been trying to draw circles and just doing a really poor job. And I did it, continually do this. I forget to put a dot to start with. My love of circles, at least in the last 2 weeks, has been waning. All right, I'm trying to draw a circle. There we go. So this is what I will hand. I will hand you a circle and a point on the circle. We'll call that point, I don't know, A. I want you to draw a tangent through A to the circle. We'll call this circle O. All right, step number one, from O through A and out a distance. Probably doesn't need to be that long, but I did it that long. All right. So here's the idea. We're basically, this is just a perpendicular. We're not making a perpendicular bisector. So I'm going to make an arc appear to the left and to the right of A, and then arcs above or below, and connect the arcs. All right. So I need to have this. Now, if you want to go to O, that's fine. I'm going to do a little bit less. Not because it's better, it's just what I just decided. Oh, that was horrible. And when you make a mistake, just remember, try not to change the distance on your compass. All right, let's try that again. There we go. And now I'm going to either put arcs above or below, your choice. So I need to open up the distance more than halfway. So I'm not going from O or from A, I'm going from this intersection and that intersection. And I'm doing arcs above or below. I don't need to do both because I already got a point from there and then from here. Okay. And I'm going to connect from A through that intersection, and that will be your tangent. Where'd my pencil lead go? There it goes. There we go. And if you want to draw a 90-degree, you can. All right. There's that one, and then we have the same construction, except the point is not on the circle. So I need another circle. Oh, joy. Oh, let's see if I can do it right this time. But not first. Call that O. All right. A lot of marks on my paper now. Oh, that mark isn't coming up. All right. Let's make a circle. Maybe I just need a new piece of lead. All right. And then I need a point off of it. We'll call that A. All right. So remember, there are actually two tangents that would hit circle O, one up here and one down here. You only need to make one of them. This particular one, the first step is not to go beyond A, so I'm going to connect O to A, connecting O to A. And then I'm going to make a perpendicular bisector of OA. All right, so remember how to make a perpendicular bisector. Open it up to more than halfway. This one I do need arcs above and below. Above, below, and then also from A, above and below. Above and below. All right. I don't really need to draw a huge perpendicular bisector. All I really need is a perpendicular bisector on segment OA. So all I really need is that right there. Okay. Now what I'm going to do, this is the step that everyone forgets. What I'm going to measure is how far it is from this intersection to either A or O. So from that intersection to either A or O, you want to put a little arc, you can, you don't have to. But I need, okay, I got that measurement. Now I need that measurement from here to intersect the circle. We'll insert the circle in two spots. I only need one of those spots because I only need one tangent. So either there or there. You can make them both if you want to impress me. Okay. And these are the points I'm going to now connect to A, and those are my two tangents. So from here through that point, there's my first tangent, and here's my second tangent. And notice I went past A. You don't have to. There's my second tangent. All right. Okay. We only got two constructions left, and those are the circumcenter and center. All right, one of them is the circle outside, and one of them is the circle inside. They both start off with triangles. And if you forget which is which, make sure they're in your notes. All right, one of them is made with perpendicular bisectors, and one is made with angle bisectors. All right, so we will do the perpendicular bisectors first. So perpendicular bisectors, we pick two sides. I always choose the bottom, but you can pick any two sides and make perpendicular bisectors. All right, so this one, I'm going to choose the bottom first. Needs to be open up more than halfway. And since I'm making a perpendicular bisector, arcs above and arcs below. And then from the other side, I'm trying to be really accurate. I hate it when I can't get all arcs above. Oh, I'm sorry. Can't see anything. Arcs below. Making a perpendicular bisector of the bottom. That first perpendicular bisector, you do not know where the intersection is going to be, right? So you're going to do the entire length right there. So that was that side. For me, I always flip the paper so that I always working on the bottom. I don't know, it seems easier. So I'm going to make a perpendicular bisector this time, again, from, let's see, from this endpoint and this endpoint. Okay. So open up more than halfway. Arcs above and arcs below. So arcs above, arcs below. From the other end, let's try to be precise. I'm trying. Arcs above, arcs below. There are arcs everywhere. All right. As I look at this triangle right here, I made an obtuse triangle. This angle right here is obtuse. So when that happens, your intersection occurs outside the triangle. So I'm going to do this very lightly. Notice that that intersection now would be outside. And that's what happens for obtuse triangles, as the intersection's outside. For the other one we do, it will always be inside. The in-center one will always, but this one is not. Okay. So what are we supposed to do now? We're supposed to measure. Remember, we're doing the circumcenter here. I'm sorry, we made the circumcenter right here. We're circumscribing the triangle. So the measurement is from this dot to any one of the three vertices. So you can pick any one. And remember, the one that you pick is guaranteed that the circle will intersect. You can kind of cheat and watch. If I put it right here, I can already tell how close I'm going to get. And I'm actually not too bad. And then you draw your circle. And remember, I'm usually a flip the paper around type of person. And how well did I do? Well, this is the one that I measured. It's perfect. This one is, the picture doesn't do very good. I am just a hair off, and this one more than maybe 2 or 3 hairs off. So I just need to see that you've made 2 perpendicular bisectors. Do you need to mark the, hey, perpendicular, hey, perpendicular? No, you don't have to do that. I can tell from where your arcs are. So that is your circumcenter. That's the one that I usually do pretty good. The last one is your in-center. That's the one we're going to make with angle bisectors. I forgot, I've got to start with a triangle. It doesn't matter for this one, acute or obtuse. I'll make about another obtuse triangle again. Triangle's bigger, gives us more space to work with. Okay. Now remember, for a circumcenter, if you have an obtuse, the circumcenter itself is going to be outside. For a right triangle, the circumcenter is going to be on the triangle, and for an acute, the circumcenter is inside. But for the in-center, it's always in. For the angle bisectors, the intersection point is always inside. All right, so here's what you need to do: is you need to pick 2 angles. I always pick the 2 bottom ones, not necessarily because it's easier, because you can flip the paper around. I just always pick the 2 bottom ones. So I'm going to pick the 2 bottom ones and make an angle bisector of both. So I'll do the left one first here. All right, so I need to make an arc that goes through the 2 legs of the angle there on the left, trying to be precise. I did pretty good on that other one. Okay. And then from this intersection and from this intersection, I'm going to put arcs over here. Remember, a circle is going to appear at the inside. So the more stuff I have inside this circle, like if I draw this arc right now, you can tell it's going to go inside. So I'm going to adjust it so it's outside. And the only reason I'm doing that is because just so it looks prettier. There's less stuff. If you wanted to, I'm trying to be precise. If you wanted to, you could even erase, this portion of the, because all you really need is the arcs, right? Right here and right here. All right, connect the intersection. I'm trying to be precise, And since we don't know where the intersection is, right? Oh, I was off. Oh, darn it. And then, like I said, I'm a little self-conscious of, since I'm the math teacher, trying to make this perfect. And I'm usually never perfect. There we go. That one's better. So there's the first angle bisector. The second one I draw, and I'm going to do it from this angle right here. Excuse me. The second one, will have, the intersect. I won't draw the entire angle bisector. I'll only show where the 2 angle bisectors intersect. All right, so let's see. I need an arc through the 2 legs of the angle. And I'm going to not go through the entire thing because I know my circle is going to be in the center. And then from this intersection, I'm going to put arcs up here. So I'll open up way big so that it's not going to interfere with my circle. Not a requirement, by the way. You can have as many arcs as you want on the inside. It's just that your circle, the last thing you draw, you're going to have a lot of stuff. The other thing, too, is if you open up way far, sometimes it's hard to see where the intersection is. So, you really got to be precise. All right, so I'm lining this up. I can tell that the intersection is going to be right there. So that point right there is the in-center. Unfortunately for us, we got to do one other thing. we got to drop a perpendicular from here down to any one of the three sides. I'm just going to drop it down to this side right here. So I'm going to drop the perpendicular straight down. So this is that construction, or you got a segment, you got a point not on the segment, and you're going to drop the perpendicular straight down. So the first thing I need is arc to the right and to the left. But look, I've already got two arcs right here. So make sure you understand which arcs you're dealing with. All right. So I need arcs to the left and right. Now I can use this point right here if I want as one of my arc intersection points, trying to be precise, but I won't. I'll use that one. And is this one going to be a problem? It is. Ooh. Ooh. It's not a problem. I mean, this will work. It's just that, man, we got a lot of arcs everywhere. So from those two intersections, I'm going to put arcs right here. Any distance is fine. I'm not going to go too crazy here, but I'm trying to find precisely. And this is where the error comes in, is that you're just not, myself included, this one doesn't feel very precise. Like this intersection right here, I'm trying to judge where it is. I think it's right here. My circle will be close, but I mean, whenever you're not exactly precise, then that's where the error comes from. So from here, straight down through that intersection. Okay. So there's my perpendicular. There's straight now. Right there. And the last step is to measure that segment you just drew. So from here to here, and then from here, draw the circle of that measurement. All right, so let's measure it, trying to be really, 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 really precise. You can cheat. I mean, it's not cheating. You can tell whether or not how close your circle is going to be. If I draw this little arc right here and then put it up to here, I'm going to be off and I'm going to be close to that one. So it looks like I'm going to be another 66%. I'm covering up the picture. My shame of this not being very precise. And I can tell you, I know where my error came from. Or not error as in I made a mistake in the construction, but I made a mistake in the precision. So I clearly got two of the, I mean, this is the one that I measured, so that one's going to be perfect. This one is perfect right here, but this one is off. And it's just that, you know, some of my arcs, I just, you know, when I line things up, I probably wasn't exactly precise. This is the one that, gosh darn it, I always try and I always seem to fail on making that one exactly perfect. But those are the procedures. So circumcenter, in-center, circumscribe, inscribe. That's how it's done. And those are all the constructions. All right, so what do we got left? We got, let me share the screen with you. We've got the centroid problems. All right, so here are the centroid problems right here. Let's see, I can do this with my finger. Remember the relationship for centroid. You got a triangle. You technically you have three medians. Remember, you're going from, say, for instance, point Z to the middle of the opposite side, so point E right there. And you do that for all three sides, but you only need two of them to do the calculation. So let's see. If you do that calculation, let me do this in red. You're always going to have a small portion of the median. Remember, the two medians will intersect. So you're left with a small portion. You're left with a big portion. And you're left with a whole portion, like the whole of the median itself. All right. And then there's a relationship between this. So let's look at, I don't know, let's look at ZE. So ZE is the whole darn thing. So Z to E is the whole darn thing. The smaller portion of that would be EL. And the bigger portion would be ZL. So those are just the names. The mathematical relationship is the small piece is 1/3 of the whole. Come here, you be cooperative here. 1/3 of the whole. The big portion will be 2/3 of the whole. And the whole, of course, well, it's 3/3. How about that? 1/3 plus 2/3 equals 3/3. And the last relationship is, okay, this is the one you got to remember, is that the relationship, and I'm going to do this in blue, the relationship between small and big, so the relationship between here to here is half, right? So if I take the small piece and I double it, in other words, times 2, I get to 2 over 2. And you're like, wait, what happened to the thirds, right? And I wrote a 3 as I was talking, right? So let's throw some numbers in there. So this is this particular problem. It says that YL is 18. YL is 18. So where is YL? YL is this piece right here. YL is 18. Is that the small piece, the big piece, or the whole piece? Well, that is the big piece. So the big piece is 18. And the relationship between big and small is one is half of the other or one is double. Well, that means the small piece is 9. And it says the relationship between all of them is, well, if you add them all together, then the whole thing would be 27. So that's the relationship. So you start with this number, double it, you get that number, add them together, you get the third number. So what does the question state? It says YD. YD is the whole thing, so the whole thing is 27. Okay. I'm not going to erase the whole thing. Just going to erase the numbers, and we'll do, I don't know, 4 of these. Erase, 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 erase. All right, let's do another one. All right, so let's see what we got here. Tells us that we have K. Come here, you. We have Kn is 4. So find Kn. Kn is the small piece. So if the small piece is 4, well, that means the big piece is double that, which is 8, which means the whole darn thing is 12. So what is it asking us? It's asking us xk, and xk is the big piece, so therefore the answer is 8. I'm trying to pick ones that every single possible combination of this, big, small, or whole. So we need to do one where we're given the whole piece. All right, AV, here we go, here we go. So this is the ugly one. If they give you the small or the big, this is pretty straightforward, but notice they give us the whole piece here, right? So the whole piece is AV, and come on, AV, and the whole piece is 18.3. So the whole piece is 18.3. So I need 2 numbers that add up to 18.3, where one is 1/3, 2/3. So how do you do this? Well, if you want to do it the smart way, you see which piece they want you to find out. I want to find out QV, and QV is the small piece, and the small piece is 1/3 of the whole thing. So I'm going to take 18.3 and multiply it by 1/3. In other words, I'm dividing 18.3 by 3. So you would get 18.3 over 3. And just with a little bit of long division, 3 goes into 18, 6 times? With 0.3 left over, and 3 goes into 0.3 1 time. So 6.1. Now, if they had asked us to do the middle piece or the big piece, I would multiply by 2/3. Okay. All right. 1 left, I think. All right. So 6.1. Last one. I didn't erase everything, did I? There we go. All right, what do we got? XT is 10.5. XT is the small piece. Oh, it's the easy one. If they give us the small piece or the big piece, it's easy. It's only when they give us the whole. So make sure you got that one locked in. Well, the big piece is double the small piece, so 21. And if we add those two together, 21 and 10.5 would be 31.5 would be the whole piece. If I would literally do all 3 of those before I looked at what the question states. The question states, what is KX? KX is the medium piece, or big piece, sorry, and the big piece is 21. So final answer, I didn't circle it, did I? Final answer is the big piece, 21. And there we go. All right, so that's the entire test. The test is going to be made up of the constructions. This part right here, finding measurements of medians, and then the last piece are going to be the locus loci problems, right? It won't be a loci problem; it'll be a locus problem where you just have one condition. Like I said, I'm not going to give you any practice on that because the answer. there's no way to truly practice for it. But I will say this, the questions will be very similar to what you had for homework. So you should recognize the problem. But if you do to run into any problems, let me know. I'll be happy to help. When you're done studying for the test, as always, send me an email and I'll send you the test. Good luck.